All right, so here we go. I'm going to do 5, 6, 7, and 8 on the target round, and I'm going to get it done really, really fast. So a standard 6-sided die is rolled 5 times. What is the probability that 5 rolls are either the same or all different? Express your answer as to the nearest hundredth. Well, for you to get all the same, I mean, that's like Yahtzee, right? And in one roll, well, how many different ways can you get this? Well, you have 1, 1, 1, 1, 1, and then 2, 2, 2, 3, 4. Oh, so there's a total of 6, because there's 6 digits. So to get them all the same, there are 6 different ways to do it. Now, the different one is a little bit more challenging, a long straight, if you're sticking with Yahtzee. 2, 3, 4, 5. So if I get the first number, what are the different possibilities for my first number? 1, 2, 3, 4, 5, 6. Okay. So there's 6 ways to get the first number. Well, that means that leaves 5 more for the second. 4, 3, 2. Well, this is just 6 factorial. And I know 6 factorial is 720. So 720 plus 6 is 726. But we also need to know how many possible answers there are. Well, if I have 5 dice and I'm rolling it 6 times, that means I have 6 to the 5th power ways of getting this result. Because my first die, there's 6 ways. 6, 6, 6, 6. Because I'm rolling 5 dice. And so that is 7,776. So we have 226 over 726. That's 726. And we want to know what percent to the nearest hundredth. So now we can pull up our calculator. Love the calculator. 626 divided by 7. Oh my gosh. When I go too fast, I start making mistakes. Then go faster so I don't make those mistakes. I love it. Going too fast? No, kid, go faster. So that is 0.0.093, and then I have to round up because that 6 is going to affect that 3, 4. All right, and so what percent is that? Well, that is 9.34%. All right. Okay, this is probably the hardest question. This is one of the hardest questions. So the first thing I'm going to do is I need to find the coordinates to make this right. So I'm going to place my coordinates on a grid. 0, 0, 6, 2, 2, -2, 6. And so there are different ways I can do this. I could go, 2, 6 would be over here, sorry. And that would mean my next point would have to go right about here. But I want the least possible. And I'm going to have a positive and fairly large positives here. So I don't think that's going to work. So I also know, put my dots back in. I also realize that I could put my shape like this. And I could go for this point here. Now this looks really promising because I'm getting way into the negatives. Incidentally, I could also put the spot down here. And so I could get something that looked like this. And I would get the same deal here. Oh, look, it's not a straight line. So it doesn't matter which one of these points I go for, I'll get the same answer. So then I go back to what I remember about a parallelogram, and I realize that this has to be parallel to this, which means the slope has to be the same. Well, I'm going down 2, and I'm going over 6. So if this point here is -2, 6, I'm going to go down 2, -2, down 2 over 6. So 6 minus 2 is 4. That's my y value. -2 minus 6, because I'm going this way, is going to be -8. -8 plus 4 is -4. Now for 6 and 7. All right. Alan, Ben, and Craig all have 3 distinct ages. And they're among 5 children running a race. Assuming there are no ties, how many different orders can the 5 children finish a race with Alan, Ben, and Craig in order from oldest to smallest, youngest? So I'm going to assume oldest, second, third, right? So A, B, C. is the way it goes. And I'm going to have the other two kids in the race be X and Y, because why not? And we are going to look at several different situations. The first situation is that Alan, Ben, and Craig all finish at one right after another. So I could have Alan, Ben, Craig, and X and Y. Well, I could also have X, Alan, Ben, Craig, and Y. Yeah, you should definitely start picking up. Or we could have X, Y, Alan, Ben, Craig. So I could also flip-flop X and Y. I'm not going to write that. So there are three different ways. 3 different ways times 2 is equal to 6. So that's if we have 3 in a row. Now let's say we have 2 in a row, and the third is off by themselves. I'll use a different color. All right, so we could have A, B, and then we could have a break, C. We could have A, B again, and C breaking up X and Y. But I can't bring C over here because then I have 3 in a row again. So I could have A, B, Y, C. I could also, so that's with A and B next to each other. What about if B and C finish one after another? So I could go A, X, B, C, Y, or I could go A, X, B, sorry, A, X, Y, B, C. So it's 1, 2, 3, 4, 5 different ways of doing it. So the other way I can manage this is I could put X in front of A, right? So I could have X, A, Y, B, C. Now, that gives me 6 different ways, and then I can flip-flop A and B. So 6 times 2 is equal to 12. Now, the third way that I can do this is that none of them finished next to each other. So that would give me A, X, B, Y, C. And then obviously that's the only way I can do it unless I flip-flop those. So that would times 2, which is 2. 2 plus 6 plus 12 is 20. All right, finally, the last problem. Let a prime be defined as a 3-digit integer. So we have A, B, C, where A and B is prime, A and C is prime, and B and C is prime. So really I'm looking for prime numbers. And I'm looking for 2-digit prime numbers, and I want the largest possible 2-digit prime numbers. So I'm going to start backwards. 99, not a prime. 98, no. 97 is not, no, not. What goes into 97 that is? No, 97's prime. So we have 97, okay. 96, no. 95, no. 93 is divisible by 3. 92, no. 91. 91 is divisible by 7. It's divisible by 7. So then 90, no. 89 is prime. 88, no. 87 is divisible by 3. 86, no. 5, no. 4, no. 83 is prime. All right. So then 80, no. 79 is definitely prime. 78, 76, 75, 7, no. 75, no. 74, no. 73 is the prime. And 71 is prime. Now this is really interesting because I need 3 numbers, 3 2-digit numbers that are prime, and I have 3 3-digit or 2-digit prime numbers in the 70s. So I know that A has to be 7. And now it comes down to this 9, 3, and 1 business. So so the problem with 9 is 9 or 90 only has 1 prime number. So if I put 9 in the middle or at the end, I'm never going to be able to get 2 prime numbers out of it. It's just not possible because the 90s only have 1 prime. So I can cross that out. So really it's the 3 and the 1. So I'm only dealing with 3s and 1s. So the largest way I can do this is 7, 3, 1, and that's the answer. Because 7, 1, 3 is smaller than 7, 3, 1. All right. I hope you enjoyed our math madness, and I will speak to you tomorrow. Have a good night.